Hello, this is Mr. Brooks and welcome to Lesson 2.2, Biconditionals and Definitions. In this lesson we're going to write biconditionals and we're going to recognize good definitions. First, let's begin with a biconditional statement. If a conditional and its converse are both true, then you can form what is called a biconditional. You can either connect the conditional and its converse with the word and, or you can simply put if and only if between the two. So a biconditional statement is an if and only if statement. Let's say we have the conditional. If two angles have the same measure, then the angles are congruent. That statement is true. Its converse would be if two angles are congruent, then the angles have the same measure. Since the conditional and its converse are both true, we can form the biconditional. Again, both the conditional and its converse have to be true in order to form the biconditional. The biconditional would then be two angles have the same measure if and only if the angles are congruent. Or you could also say two angles are congruent if and only if they have the same measure. Now I'd like you to try to create a biconditional. I want you to look at the true conditional statement. If 3 points are collinear, then they lie on the same line. True. Now I want you to create the converse, write the converse for that, and then if that converse is also true, combine the statements into a biconditional. Please pause the video while you try to come up with the converse. Hopefully you agree the converse is if 3 points lie on the same line, then they are collinear, which is also true. Now try to since the conditional and the converse are both true, try to create the biconditional. Please pause the video while you try to figure this out. Now I want you to look at the following biconditional statement and see if you can turn that into two conditional statements. A number is prime if and only if it has two distinct factors, one and itself. That's a biconditional because it's an if and only if statement. I want you to turn it into two conditionals, two if-then statements. Please pause the video while you try to figure out the two statements. Hopefully you came up with the two conditionals, which would be if a number is prime, then it has only two distinct factors, one in itself. Or the other one would be if a number has only two distinct factors, one in itself, then it is prime. Part 2 in Lesson 2-2 talks with recognizing good definitions. Basically, there's 3 parts to a good definition. A good definition uses clearly understood terms that should be commonly understood or already defined. A good definition is precise and avoids words such as large, sort of, and almost. And lastly, a good definition is reversible. That means you can write a good definition as a biconditional. Let's try to decide if this definition of a right angle is a good definition. Again, if we can write it as a biconditional, then it's a good definition. If it is reversible. First, see if you can change this into an if-then statement. A right angle is an angle whose measure is 90. Try to write that as a conditional. One conditional would be if an angle is a right angle, then it measures 90. The other would be if an angle measures 90, then it's a right angle. Now pause the video while you try to make this into a biconditional. The biconditional would be an angle is a right angle if and only if it measures 90. Or you could switch it around and say an angle measures 90 if and only if it's a right angle. So we see this is reversible, therefore it is a good definition. This concludes Lesson 2.2.